Did you hear me mention S-wave shadow zone when I was speaking about the core? We're going to take a deeper dive into the core, a place no human being has ever been. Well, if you look at these two diagrams, let's start with the one on the right that says P wave and S wave shadow zones. As I told you, both the P wave and the S wave, which are body waves, transmit through the Earth, not along the surface, through the Earth. You can see if you look at that diagram closely, at the top it says epicenter with this little circle. Then it shows the waves transmitting through the Earth. Well, along the road to articulating the liquid outer core, something was discovered. And what it was this. Every time there would be an earthquake on one side of the planet, on the opposite side of the planet, so let's say an earthquake happens in Los Angeles and then in South Africa, what they noticed is that they would receive P waves, but they would receive no S waves. You can imagine how much study, how many earthquakes, how many people sharing information were needed to come up with this. That's the way science works: evidence, fact, and replication. What they began to find out is that no matter where the earthquake was, on the opposite side of the planet, there was this consistent S-wave shadow zone. A zone where no S waves were received exactly on the opposite side of the planet, and then spread out, if you look at the diagram on the left-hand side, across that entire bottom part of the planet. Or if you move that red star around the exterior of the planet, the circumference of the planet, those same waves would strike out in exactly the same way. When they saw this, the question became, why is that? So what do you do in science? You study the S waves. And what they found out is that S waves do not transmit through liquids. Ergo, they must be hitting liquid. And this helped lead to the articulation of the liquid outer core. You can see with that red line I just drew, that's the S wave shadow zone, and it's consistent no matter where the earthquake is. You just spin it around to the other side of the planet, and there is this shadow zone that happens because the S waves are running into the liquid outer core. Because the inner core is solid and the liquid core, the outer core, is liquid, the inner core sort of rotates rapidly inside of that outer core. And because of that, we get the creation of our magnetic field. And in fact, if you look at this diagram, you can see that if you're holding a compass in 1900 in the northern hemisphere, the compass is going to point to a different place in 1900 than it did in 1996, because the magnetic North Pole moves as a result of this rotation and the currents that are happening within the core. There you can see with the yellow arrow that rotating inner core, the solid inner core that rotates in this very fluid liquid outer core. Again, you could see with this diagram that rotating inner core and the convective currents, and then the magnetic field that's formed around our planet, like this. Why is that magnetic field important? It's not just for a compass if you're moving around on the planet. It's because our magnetic field protects us from solar winds. As the solar winds move along away from the sun, they strike our magnetic field, and as a result of that, go around us. If they did not do that, our atmosphere would be blown away and we would not survive on this planet. But the fact that we have this liquid outer core, which allows this movement in the core, that creates our magnetic field. The moon, solid, basically all the way through. Mars was once very active. The biggest volcano in the entire solar system, as far as anybody knows, is Olympus Mons. It's like 2/3 the size of the United States. So it was active at one point, but Mars hasn't been active for something like 3 billion years because it has mostly solidified through. As a result of that, it lost its magnetic field. Because of that, the solar winds blew its atmosphere away. We know with certainty there was running water on Mars at one point. There are canyons, river valleys, deltas, All of these things exist on Mars. They're just dried out because the atmosphere got blown away when Mars solidified through. Mars is a smaller planet than Earth is. So it's critical for our planet that it operates the way it does. I mean, take a look at Mars on the right-hand side. It's embarrassing. Would you really want to live on that planet? Come on, did you see the Matt Damon movie? Mars is terrible. Now we're going to be off to play tectonics.